Hello guys, welcome back to the hybrid model for another engineering talk. My name is T and let's get into it. So today the engineering talk is going to be on Django unit testing. Now, Django is a framework used to build web applications using Python, and naturally with any application you write, you want to unit test it to make sure it's fit for purpose and ready to release to your target audience. And so, in the engineering talk I'm about to present, uh, I am going to uh, talk about some techniques and strategies that you can use to test your Django application to make sure it's ready to go. Really. So yeah, let's jump into that and crack on. Hello again, and welcome to. Is this the second engineering talk? I can't remember now. Maybe the second. I can't remember. Uh, and yeah, welcome to the second engineering talk. And today we are focusing on Django REST API unit testing. And there's a reason I specified REST API. I will explain that in a minute. But yeah, so I'm just gonna kind of set the lay of the land. I am going to introduce kind of the presentation, Django, the framework, and point out some differences between Django testing and Python testing in like a summary manner, if you will, and then we'll dive straight into kind of the code and talking about writing tests and all that good stuff. All right. Oh, yeah, if you guys have any questions, just write them down and we'll address them at the end of the presentation. Yeah. Okay, let's go. Okay, that's working. So, but in summary, Django is a Python framework or library, depending on how you look at it, that allows you to write web applications or REST APIs, essentially. It's built on top of Python, so it does benefit from all the good stuff that Python offers out of the box. That's, yeah, pretty much all I'm going to say about that for now. Oh, and also, Django does come with its own security features. I don't know if you guys know this, but it has a lot of security features built in, which is quite handy because it means you don't have to worry about building in security features for your web application like you used to have to do with other frameworks back in the day. It was like eons ago now, but it's almost like just a decade ago, to be fair. So yeah, that's another good thing about Django. It's actually, I dare say, the best. Now I'm gonna say it. It's the best web framework ever created to date at the recording of this presentation. I don't care what anyone says. This is it. So the reason why the title was specified to be Django REST API is because Django has two aspects to it. There's Django REST Framework, which is what we use to build the REST API stuff. There's also, okay, I've coined it Django Web, but it's just Django. That's the original Django, was you could build web applications where the UI was also baked into the Django framework. So you just use, I think they call it Ginger 2 templating, and write HTML files and then just pass the data you wanted between the view and, not the view set, but the view and the template, which was the HTML stuff. And I believe that's still well used today. Now, for our scenario, we use Django REST framework, and then we have React handling the front end for us, which is also good. But that then provides a big difference in how you write tests, basically, when you're addressing for both, because in one element, the Django REST framework, you only care about the JSON output, basically, and behavior around that, because it's a REST API framework. Whereas with the web, you might care about what the front end is outputting, or what's in the HTML on the front end, because what the user sees would be different, essentially, if they were to interact with Django directly. So that's just a quick summary of those differences. Now, when regards to testing, the differences between Django and Python, it's a small difference. It's a small but big difference. Now, I know what you're thinking. What the hell does that mean? How can it be small and big at the same time? So the reason I say it's a small difference is because Django sits on top of Python, you get all the baseline Python unit test framework that like Python offers basically. So you can just use that. However, because you're also dealing with the REST API, you have to deal with web API behavior as part of your testing. So you're not just testing random modules or functions or classes. You have to deal with a web kind of infrastructure, if you will, on top of that. And usually with some sort of REST API, there's kind of an authentication process, right? There's very few REST APIs where you don't have to authenticate to some degree to then gain access to said REST API and its functionality. So as part of your testing setup for Django, you have to kind of address that initial authentication, because otherwise your test will fail, because they'll be like, I don't have access to the rest of the endpoints because they require authentication. I think except for the authentication endpoint itself, everything else is behind a security door, basically. So that's kind of one of the big differences there. Whereas with base Python, you just test, you don't care about authentication, unless your application does care about that, which most don't. So that's a, I guess, quick-ish summary of the differences between Django and Python. Let's get into the code, the good stuff. So I have coined this slide the setup, because this essentially showcases kind of the baseline setup you would need to do as to kind of before you can start testing for anything with Django, because now this is all Django now, by the way. And don't worry so much about the color schemes. It was me just trying to kind of separate the different functions, the different methods and different kind of levels of the test setup, except for those imports. That's directly from the IDE. Like, I just left that because I was like, that's cool. He just kind of imported the color scheme as well. So there's two options. And the reason I put two options is because there are two scenarios where you can set up your API test case. Option A is you use the, sorry, no, how do I say this? So before I talk about the options, so you probably noticed that the two options are quite similar. It's just a bit different, but similar in terms of the setup is you create a user with the password, and then in the setup at the bottom, you then log them in, essentially, right? And the client class in the setup is what allows you to log in and mimic the behavior of an authenticated user in the test framework, essentially. Another thing you might have noticed is, instead of just using test case at the, do I have my mouse? I don't know if you can see my mouse or not, but we have API test case instead of just test case, which is what we usually use for like Python. And the reason is because we are specifying that we're actually testing an API, a REST API. So we have to be specific. If you were testing a Django web application, you would just need to import test case, but you take it from the Django.test library, basically. But the same setup will be the same. It's just you wouldn't be testing a REST API, just a web API in that respect. So that's just a small difference, but you guys don't have to worry about that much, because we use a REST API. So API test case is good enough. Right, so yeah, back to the setup. So for both options, we create a user and then we log them in using the client. And this is kind of universal across the REST API, because again, you need to be authenticated as a user to then be able to do anything else within the test case or the test framework, if you will. Now, option A showcases setting up a user using the user model directly. And this is great, and it's not a problem, it's fine, right? Django is designed to do this. But it does mean you are doing a lot of the heavy lifting yourself, creating the objects, managing them yourself for like the user, for example, right? And on the option B, we're using a factory fixture, so the user factory, where all the boilerplate stuff is hidden underneath, and yeah, you don't have to worry about kind of managing it yourself. You just tell the factory create X and it does it, and then you just continue. Now, unfortunately, the choice of using the user here doesn't show the benefits of using a factory that well. It would be better with a more convoluted setup where you had to create a bunch of different objects ahead of time. That's when you'd see the beauty of factory fixtures within a setup like this. But in this case, it's not that beneficial. In the future, I might do a separate engineering talk on factory fixtures directly, just to kind of express their power and their beauty as well. But for this one, these are the two options, and either one works. If you don't know how to use factory fixtures, you can just go directly and use the user objects. If you do know how to use factory fixtures, option B is probably the better one. Another thing I wanted to point out is currently in both examples, I have a setup test class method where you're creating the user object and then logging them in the setup, right? This is, I guess, the most efficient way of doing it, because it means you only create this user once in the test class, setup test data, and then you use it throughout your tests within this class. But you could also just create the same objects within the setup function. Hell, you could do it for each and every test if you wanted, but again, that's just repeating code. And I think clean non-repeating code is better. And setup test data just makes it so that it creates the object once at the beginning of the tests and doesn't recreate it. In setup runs every single time a new test is running that test case. I don't know if you guys knew this, but that's kind of how Python rolls. So the setup method runs every single time for each and every test. So if you have 10 tests, setup will run 10 times. But setup test data only runs once, the first time, whichever test runs in that test case or test class. Setup test data gets run once, and then everything, whatever it creates, the objects persist throughout that entire test class until it's finished. Ergo the efficiency. So that's the beauty of that. But don't think this is the only way to set things up. It's just the most efficient way. Yes, I think I don't really have anything else to say about this section, so we're going to move on. So that's the setup. Oh, by the way, keep this in mind for the next slides, because I don't repeat this code in future slides because I had to fit the code in somehow, so I had to strip out some stuff. So just imagine this for any test I talk about in the future slides. Just imagine these setups are there in the test case somewhere. And then, yeah, just know that it's all good. Okay, so in this one, for most of you who've used Django, you probably notice some similarities. Again, the color scheme on the test side is just to separate the tests, just a separation. So yeah, it doesn't mean the others are bad or not. I just had to choose a color scheme to separate them. But this is quite familiar. And this is, I guess, the simplest version of any set of tests that I could bring about as a basic unit testing structure for a REST API in Django. So you have the view set, which, excuse me, in this case is for the account model. And I mean, it doesn't say, but it will do all the create, read, update, and delete stuff, functions, essentially, with just those 3 lines or those 2 lines in the view set. It handles everything, and the serializer just determines which fields are going to be presented and accepted when you're doing either one of those operations, right? So this is like the basic stuff for Django REST framework. On the test side, you probably see the differences to the previous engineering talk, where the tests are slightly different. So in this case, we have 3 tests, and the most common thing in there is the self.client object, which, if you remember, is the client that authenticates in the setup. And for, I guess, the first 2 tests were retrieving data. And yeah, just trying to make sure the data is correct. I want to reiterate that these tests are testing the behavior we expect, because that's a big thing for me personally, is the behavioral driven testing or driven development, whatever. So they're testing behavior. So we expect that if we only have, actually I should say this, I forgot to say this. So in this case, for the first test, where it's listing all the accounts, that test is actually wrong because I haven't shown you a scenario where I've created an account, right? So let's pretend there was no account that was ever created. We have 0 accounts in the system. We only have the 1 user in our setup. And I say, get me all the accounts. And then I say, I expect there to be 1 account as account in the response. That should fail because there's no evidence of me creating an account either as part of this test or in the setup, right? So this test would fail. But let's pretend I had created an account using either a factory fixture or the model itself directly. It doesn't matter. Then it would be at least equal to 1 because there'd be at least 1 account. And that's just like a baseline of testing for that type of test, where you're testing for a list of objects to be returned. So that's just one thing. I just want to clear that up because I realized I didn't actually provide the account that we're testing for, essentially. Same thing with the second one for the retrieve account. I referenced self.account, which implies I've created a class level object for the account in either the setup or setup test data, whichever one. And this would pass if that was the case, but if self.account didn't exist, it would throw an error of like saying self doesn't have an account object or something. I think that's the correct error, attribute error or something, yeah, or something like that. But if those things exist, then that test also passes. Same thing with the create one. So that's just a post request, right? And you could potentially replace post with put and even patch, and this would just work, but the response will be just different. I just didn't put those tests in because, yeah, I didn't have space. That's the truth. And post, put, and patch have some similarities, so there was no real need. The one thing I would reference is at the bottom, I retrieve the most recently created account and then check to see if the name is equal to the one we actually sent in. And I'd say that's quite critical when you're doing tests, is to make sure the objects you expect in the database is like the most recent thing, or whatever it is may be, that it's actually stored the correct information, because there are times where your tests for the REST framework will say, yep, everything's good, but they didn't store anything in the database. And it could be you didn't handle an error properly, or you handled an error, but you didn't then do anything with the error that happened. Like you didn't report it back, or something else happened in the Django framework that I can't even explain. And so you always need to make sure that the behavior you're expecting, which is it will give me a certain response, like a 2 or 1 for, yes, we've created an object, is returned, but also that the actual data we sent to the REST API has been stored in the database. It's pretty critical. I've been caught off guard quite a few times when I thought the response was enough and then realized there was some database operation that was failing. And the test weren't catching it because I didn't kind of put an assertion for that to check it. But overall, this is just basic unit testing for Django. And so now we're going to talk about some, I say fun stuff, but I don't know if everyone agrees with me. So mocking in Django unit testing has some similarities to mocking in like basic Python, essentially. It has some similarities and there'll be some differences, and I'll explain. So this is kind of like okay, I'll be honest. This is the worst way to introduce something that needs mocking in any Django behavior, especially a REST API. No one in their right mind would put the S3 connection behavior stuff in a view set. That would be ridiculous and insane. I did it just to portray what I'm going to explain now. But usually this stuff would be like in a serializer sometimes, but usually somewhere else, like a signal or something. But I don't want to get ahead of myself. For now, we're going to pretend I'm the idiot who decided that I want to retrieve elite account data from S3 and do so, and then filter the query set for the account with it, because I'm insane and I said to put that in the view set because I love slowing down my REST API, even though it's supposed to be almost like asynchronous. I digressed. So as you can see, if a request parameter is for the elite is sent in, we then go to S3 and do some stuff. Now, for testing this on the right-hand side, we would specify the viewset module. So wherever this is, the viewset is based, and then specify S3, which is just the S3 method that we're using to connect to S3. And then that's us mocking S3 straight up to just prevent it from, to prevent our tests from actually trying to connect to S3, because that's a whole different topic. And then we set some, I guess, data we pretend is coming back from S3. So in this case, I've said when you connect to S3, the get object function will return that response basically, which is just IDs in a JSON object. This essentially means that as of now, the S3 connection doesn't happen, but we still get the behavior we want to test, and then we expect there to be 3 objects in the response, and that's why I put 3 and 3 for both, just to showcase that you can have more than one as an expected response for the count. And then just make sure the connection to S3 is actually being called, the mock anyway, sorry, I should say, is being called, and then, yeah, that's pretty much it. One thing I want to mention is I've used assert code once, and that's because in this example, S3 is being called once, the mock is being called once. If in the view set there was a loop there happening, you couldn't use once. It would tell you that the mock for S3 is being called multiple times, so that would fail the assertion. You'd have to just use assert code, or I didn't put this in here because I didn't want to kind of go that far, but there's something, I'll just mention it now and do, can give some examples offline. But there's what's called assert has calls, where you could check if you know that, for example, the mock is going to be called multiple times, and you kind of know what's being called and what kind of data is being passed in as part of that call. You can literally say, I expected these calls to be called by S3. Do they happen? And you can put however many they are, and then that assertion actually checks, like, more explicitly if the calls we expect are happening. Now, I've done this a few times in our code for 4D. You probably could search assert has calls. So it's assert underscore has underscore calls, and you could probably find it. It's probably in the avocado section, not in the 4D section, like in the REST API section, so I should say. I can't remember now, but it's quite convoluted, and as a starting point, I wouldn't advise going that deep. It's mostly just keep it simple to assert code or assert code once. It's good enough. And then, can expand from there. Now, because I love behavioral driven testing, I had to put in a second test, the one in orange. I think that's orange. Yeah, the one in orange, where I check to see that if I don't provide the elite query parameter, that S3 isn't called at all, right? Because you want to make sure that it's also not called. So that's also important in testing, just to test that, I guess, is this a failure or like a different type of behavior is exhibited, I should say, when different parameters are provided. In this case, we don't expect any elite accounts to be returned, so we expect apparently one account to be returned, which is in our database, that isn't elite. And yeah, just the assertion, just make sure that we didn't call S3. So that's, in some ways, it's similar to the Python unit testing in terms of mocking. You probably noticed that. And yeah, it's quite I'll say simple. It's quite simple. I don't know if everyone agrees with me, but I firmly believe soon everyone will be comfortable with like unit testing, and then you guys will become rebels and start doing crazy stuff with mocks and stuff, and it'll be fun. So yeah. Anyway, let's move on. So signals. So this is now kind of where we dive more into Django specific testing, because Python as a language doesn't have a concept of signals, because, well, yeah, it doesn't. And signals, as a summary, because I know most of you guys know what they are, is essentially a trigger to say, if changes are made to a model, I want this set of behaviors to be done. And usually with signals, you're usually trying to interact with the outside world from the REST API, which is S3, sending emails, I don't know, sending things to SQS queue, or interacting with third-party APIs or something. I don't know, a bunch of different things. Now, the example I put in here where I was doing the S3 thing in the view set, which I said was dumb, that's because usually speaking, you'd put that kind of thing in a signal, because signals handle different states of a model, not just post-save. I just use post-save because it's the easiest one, but there's a bunch of others. I'm not going to go too deeply into those. But essentially, we have a signal that essentially gets triggered when we save an account object, whether it's new or making update changes to it. This will be triggered, doesn't matter. And in this example, we are sending the email. We're just sending an email. Apparently, we're saying hello world, because that's easy. So in the test side, because the signals are not part of the view set, they're separate. This is where things get interesting. So you probably noticed that instead of specifying the module as the view set module, because that's where the actual test is running, the tests are running the view sets. That's what they're running, right? But the signals are outside the view sets. They're triggered elsewhere. So we actually have to go and mock the signals module to get the like send email or whatever function we're trying to mock. And I've had some debates with a few people about this, where some disagree that this is a good way of mocking. I personally don't like this kind of mocking, but I haven't found a solution that's better, because how else am I going to mock the signals module without specifying it? Otherwise, the REST API will just be like, I don't know what that is, because you can't trigger it anywhere else, because it's done in like at the database level. That's where the trigger is done for the signal. So I have to kind of mock the actual signals module, which is incorrect, because usually the mock is about where the functions that you're testing are being run from, which is usually the view set module in this case. But like I said, signals are triggered from the view set module. So I've had debates with people about this, and no one's come up with a better solution. So I deem this to be correct, but I still don't like it personally. But it is what it is. Gotta roll with it. So yeah, in this case, we mock the send email signal, and then we just check to make sure it's actually called, essentially, but we're just preventing it from actually being sent. Because if we didn't mock the signal, that email would be sent, even if the actual email was like a dummy email, it would still be sent, which is a problem. Now, there are other ways to prevent emails from being sent, but that's diving deeper into Django's security features, and I don't want to do that because that's a whole different topic. So this is the easiest way to do it. Just mock those signal functions, and you're good to go. One thing I will say is this. Oh my God, I just realized a mistake. Yeah, ignore the bottom one. I just realized that's a duplicate. It shouldn't be there. Apologies. I forgot to remove that. It's just a duplicate of that. I can't remember what I was trying to do there, but it doesn't matter now. Ignore the bottom one, the red one. Just ignore that. One thing I was going to say is, in this example, I mocked send email because I actually wanted the rest of the signal to run, right? But as some of you might have noticed, for 4D, we do have some quite convoluted signals where it might be difficult to test a specific like function or set of functions that do the third-party stuff. In those scenarios, I'd encourage you to just mock the entire signal. So you could actually just mock create new account in this case. Instead of send email, just put create new account and then just say, was that code? Which it would have either way. The rest of this test would work either way. And that's another way to kind of get out of it. But I would only say do that if you cannot, for the life of you, figure a way to actually just mock what needs to be mocked out, i.e. the functions be interacting with the outside world. If you cannot mock them easily within a signal function, just mock the entire function. Just mock the entire signal function. There's no need to fight that because we're just trying to prevent unintended consequences from happening, and then we can deal with the rest afterwards. It's a good starting point. I actually think I've done that before for some of the tests in the REST API where I couldn't get it to work the way I wanted, so I just mocked the whole thing. I can't remember where I did that, but I'm sure I remember doing it somewhere where I kind of lost it. I was like, screw it, we're mocking the entire thing. So yeah, that's that. I don't have much to say here. Okay, let's move on. So next one is mocking side effects. So I don't know if you guys remember what side effects are from the Python engineering talk I did like almost 6 months ago now. I don't know if you guys remember that, but side effects are essentially where you are trying to trigger failure within whatever you're testing, usually with mocks to see what if the behavior you expect still happens. So in this case, our signal function now has two functions it runs. So the first one is the send email that we expect. And the second one is a function that adds a message to a queue, right? Now, on a good day, both mocks would run, right? We'd expect that because there's no reason. But in this case, we want to test to make sure that if we raise an exception, for example, with the send email, if the send email fails and raises an exception, that the add message to queue never gets run because, well, if send email fails, we don't want to continue, right? We just want to jump out. And our exception try except handles everything and just returns the instance. And so in our tests, that side effect is actually what we're testing. Basically, we're testing to make sure that send email raises an exception and the mock for message to queue doesn't actually run. And this is how you'd set that up essentially. So I purposely put the Apache, anything to do with the mock for message queue in blue, just to separate it out. And as you can see, we expect the assertion to be a certain code, because if it's code, then that means either our side effect is wrong or we have a problem in our signal. And yeah, that's pretty much it. It's a kind of a good test. Yeah, it's pretty much that for this one, really. There's not much to speak about. Unfortunately, there's not much I can say because most of these things are covered in the initial Python engineering talk. But this is just expressing how Django would handle most of this stuff. And that's that. So one thing I wanted to mention is I purposely only focused on the REST API for this one because I didn't want this engineering talk to kind of go on for like the next 5 hours, because Django is a bunch of other things that need testing that we as 4D actually work with, like management commands, for example, being a good example. And testing for those is it's a whole different ballgame because they're not web APIs. It's kind of like a console application in some ways. So I will most likely do a separate talk on that just to kind of keep these a bit shorter and more concise. That way people can just go to what they need at a given time. So yeah, I hope you enjoyed that one and found it helpful and informative, and I don't know, provided insight into half the test I've written in Django and what it all means. essentially, at least for the REST API.